Welcome back. We're going to go ahead and take a look at matrices. This is going to be the beginning of several back-to-back videos where you learn about row operations, finding inverses, and then eventually reduce row echelon format of matrices. So we're going to begin with some vocabulary terms here. Notice I've labeled this as matrix A, this as matrix X, and this as matrix B. I've put the brackets around them because this is the consistency that you're going to see inside the calculator, and I'd like you to be able to relate all of these things to what the calculator operations are going to eventually do. You'll notice over here that I've automatically placed in the calculator steps, so you're able to look through those as well. Alright, so A is known as the coefficient matrix. X is known as your variable matrix. And B is known as your constant matrix. We're going to look at that in a little bit more detail in just a few minutes so you understand why each of those are named the way they're named. The way that you would solve this equation as though it were just numbers, we have matrix A times matrix B times matrix X equals matrix B. So in order for us to solve this using just order of operations, we would simply divide A over to the other side of the equation. Now, multiplication and division are inverses of each other, so basically what we would do is we take the inverse of A and multiply it by B to find the value of X. That is exactly what we're doing here. Therefore, A to the -1 power is known as your inverse matrix. Now, all we need to do to find our inverse matrix is to go ahead and follow these keystroke patterns here, and we'd be able to figure that out. So what I want to do next is bring up the calculator so you guys can see exactly what it is that you need to do when the calculator is being used to solve matrices. So you're going to want to follow through these keystrokes so you can see exactly what's happening with the calculator. And the first thing you want to take a look at is the matrix button, which is second x to the -1. And you're going to bring up a whole bunch of different matrices. Now there's a likelihood that these are empty for you, so you're just going to have to fill them in as we go along. These are the names. This is how you retrieve the matrix. This is the math. We'll talk about that later when we get to reduced row echelon format. But the most important part is your edit. What I like to do is push the left arrow. That brings me to the edit screen, and then I'm going to go ahead and get A. Once I go into matrix A, I first have to tell the calculator how many rows and columns I need, so 2 by 2, to enter, and then you're just going to fill in your addresses as they go along. The calculator will go row, 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 across like this, so just hit 3, enter, 2, enter, 4, enter, 3, enter, and it'll fill it all in for you. Now I'm going to go ahead and I'm going to quit out of here, go back to the matrix screen. It's important that you get into the habit of quitting, that way you won't insert a matrix into a matrix. I'm going to retrieve by staying on the names menu, and then what I'm going to do is I'm going to hit the -1 to give me the inverse, and the inverse matrix is that. Alright, and that is exactly how we solve matrices. I wanted you to do the inverse on your own, but go ahead and take a look at question number 3, and we'll just kind of continue on as we go. So the reason why we call matrix A the coefficient matrix is because we use the coefficients of the two equations in the system as our matrix A. So that's going to be 4, 5, -1, and 1. Then we follow that up with our variable matrix X and Y. We're going to see that change in question number 4, and I'll show you how that works in just a minute. And then our constant matrix is going to be our numbers, which in this case are our solutions, but in every case they are our numbers that do not contain variables. That's why they're called constants. Alright, now of course what I need to do here is I need to find the inverse of matrix A. So what we're going to do here is we're going to follow these keystrokes here to help us out in solving this problem. So I'll show you how this works. I'll come back up here so you can read the entire thing and follow along with me. Essentially, what we're going to do is we're going to find the inverse of matrix A. We're going to multiply that by matrix B, and the result of that is going to be the solution matrix X, Y, or sorry, the variable matrix X, Y. And that's how we find our solution to this problem. So back to the calculator, here we go. We're going to go in to the matrix, edit matrix A, pass through the rows and columns because they're still the same, fill in your numbers, quit out of the matrix, go back to the matrix again, edit. This time we're going to edit matrix B. You likely don't have this matrix inputted yet, so it's 2 rows by 1 column, and that's going to give you the proper matrix to insert your constant matrix into. Quit out of there, and then remember we're going to take the inverse of A and multiply it by B. That's how we're going to find the solution X and Y. So we're going to go ahead and go back to the matrix. This time we're just going to retrieve matrix A, take its inverse, and then we're going to multiply that by matrix B. So once your calculator screen looks like this, you're going to get the solution of -2, 1. And that is the solution to X and Y. So you write it like this, and that gives you what you're looking for. All right, the matrix tends to be a very simple way for you guys to solve problems, so just keep that in mind as you're working along. Now question number 4 throws a little bit of a wrinkle in here, so we're going to take a look at that because of this right here. You got a 100-pound mixture. It's not 1 pound, it's 100 pounds, and that's going to affect one of our equations very in an important way. So I'm going to go ahead and say French roast coffee, F, is going to be $5.20 a pound, plus the Colombian roast coffee, which is $4 a pound, is going to give me a total amount of $4.72 if I only buy one pound of it. But in this particular problem, I'm not buying 1 pound of it, I'm buying 100 pounds of it. So that means if I buy 100 pounds, I'm going to multiply $4.72 times 100, giving me the total number of 472. Now if you don't do this, it'll throw your numbers off, and that's why people get confused when they look at this problem. Just remember, you're not buying 1 pound, you're buying 100. The total amount of pounds of French roast and Colombian roast are going to be 100 pounds. And now I'm going to go ahead and use these variables, even though they're for the next problem, to help me kind of structure my matrices. So that's 5.2, 4, 1, and 1. This is not going to be X and Y this time because it's a real life example, so I'm going to go ahead and use F and C. And then this one is 472 and 100. And now I've got my constant matrix, my variable matrix, or sorry, my coefficient matrix, my variable matrix, and my constant matrix. Remember, we're going to make our calculator screen A to the -1 times B. All right, back to the calculator we go. And back to the matrix we go. I'm going to edit matrix A again and simply overwrite the numbers that are currently there. 5.2, 4, 1, and 1. All right, quit, enter into the matrix, edit matrix B, overwrite the numbers that are there, 472 and 100. Now the nice thing about this is that your previous entry already states A to the -1B. So all I need to do is hit enter again, and the calculator will calculate the new values with the new matrices that have been placed. Okay? All right. Question number 5. We're going to go ahead and take a look at this using 3 variables. No different, just a little bit more complicated. Please understand that the matrix loves structure. So what's missing from the second equation that's in the first equation? That is the value y. Please remember that if it's not there, it's 0. So that's going to be placed in the matrix. And in this one, the value that's missing is x. You'll also notice that the value of y and z are out of order. You must rearrange these appropriately in order to get the right answer. Please be very careful and mindful about the order of the variables and keep them the exact same every time. If you do not, you will not get the right answer. All right, so let's take a look at our coefficient matrix. That one's simple, 1, 1, 1, okay? 2, we said y was 0 and z is 1, so we pushed that out of the way and put y in the middle. We said x was 0. Notice the y and the z have switched. That's why the -1 goes in this place and the 1 goes here. Now we're using x, y, and z, and we're going to follow that up with 0, 12, and 3. All right, now what you're going to have to do is you're going to have to create a new matrix, and you'll see that I've already done that in matrix C and matrix D. Since we'll be doing this so many times, what I like to do is I like to leave my 2 by 2 and my 2 by 1. That way I can insert into there when I need to, and then I write my 3 by 3, 3 by 1, so that I can insert in there when I want to. So I come down here, and it's 3 by 3, okay? 1, 1, 1, 2, 0, 1, 0, -1, 1. All right, that's already set and ready to go. I'm going to quit. I'm going to go back again, edit, this time matrix D. It's a 3 by 1, 0, 12, and 3. Quit out of here. Now I can't just do this because now I've used new variables, so I got to go back again, retrieve matrix C, inverse, and multiply it by matrix D. And that's going to give me my solution of 7, -5, and -2. And so the solution looks like this. X, Y, Z equals 7, -5, -2. And now I'm finished. I want you guys to take a look at question number 6. Pause the video now and go ahead and take a few moments to write your equations. Remember, there are 3 variables, so there are 3 equations that you're going to need to find. Go ahead and rearrange it into a coefficient matrix, a variable matrix, and a constant matrix, and then see if you can find your solution. Hopefully you've taken the opportunity to really go through that properly, and you're looking just to check your work right now. So here is the solution that you are looking for. Coefficient, variable, and constant matrix.